In the previous video, we have discussed about the universal and existential na quantification. Okay, as you can see here, we have the expression for all x p of x, and this denotes the universal quantification of a certain predicate p of x. So this expression may be read as for each x, or for every x, or for all x, p of x holds. And this symbol represents the universal na quantifier, and pairing it, let's say, with the variable x, it means every object x in the domain of this course. So if objects in the domain of this course can be listed, we can represent the universal quantification with conjunction. So for example, we have a domain D that contains a list of some computer science na faculty members in UPB, and we have, let's say, a predicate male of x such that x is male. And then, assuming we have a universal quantification for all x male of x such that x belongs in the domain D. Okay, so in order for us to obtain a truth value for this quantification, what we have to do is to plug in each element of the domain into the predicate male of x and connect them with the and na connective or the conjunction. Okay, and so then for each na predicate, we can obtain a truth value. And this whole na expression results to false. Why? Because some of the faculty members are not male, like Ma'am Almi or me and Ma'am Christy, it will result to false. And while the other members are true. So since they are being connected with the and only at least one false is needed for this to result to false. So this existential or this universal quantification for all x male of x in the domain D will result to false. Okay, so again, this can be represented by conjunctions, and it requires each of the predicate male of x to be true for every x in D, or every x in this domain D. Okay, hence we can say that the universal na quantifier is sensitive to false value because only one false, at least one false, will make the whole expression become false. Recall also that this expression, there exists x p of x, denotes the existential quantification of a certain predicate p of x. This expression may be read as there is an x, or there exists an x, or for some x, p of x holds. So this symbol is the existential quantifier, and pairing it with some variable, let's say x, it means at least one object x in the domain of this course. So if the objects in the domain of this course can be listed, we can then represent the existential na quantification with disjunctions, or characterized by the or connectives. Okay, suppose we have the same example. We have a domain D that contains a list of some computer science faculty members in UPD, and we have a predicate male of x such that x is male. And then we have an existential quantifier. There exists x in the domain D, male of x. Okay, so this means that there are some computer science na faculty members that are male. So in order for us to obtain the truth value of this existential quantifier, we have to plug in every member of the domain D to this predicate male of x. So we result to this expression. And by doing that, we obtain a truth value. Since some are not male, so it will result to false, and some result to are male, so it will result to true. And being connected by the or connective, this existential na quantifier, there exists x such that x is male in the domain D will evaluate to true. Okay, so since this existential na quantifier can be represented by disjunctions, it needs at least one x, or at least one person, that will make this predicate male of x become true in order for the whole expression, there exists x in the domain D, male of X, to be evaluated true. So what we can say here is that the existential na quantifier is sensitive to true value. Or in the other words, at least one true will make the whole expression become true. Okay? So the domain of this course acts as a universe for to contain objects that are not similar to each other. The domain of this course acts as a universe for our interested objects and will only be defined once. Therefore, it is possible for the domain of this course to contain objects that are not similar to each other. Like, for example, it can contain different objects from different categories, like cars, people, parking lots. And in the previous example, we have shown you a domain D that contains people of different gender. Okay, so to narrow down our interests to a specific kind of objects, we need to restrict the domain of this course. Okay, and we can do this by adding rules to restricting a domain. If a certain variable is universally quantified, then we can restrict the domain by making the domain of X an external hypothesis. So does this sound familiar to you? It means that we deal with implications. Okay, and then if a certain variable is existentially quantified, we restrict the domain by making the domain X an extra on a condition. So in other words, we simply have to use the and na connected. Okay, we will try to understand that as we go along. So suppose we have a domain DPSM na faculty, and the DPSM faculty contains a list of different faculty members from ComSci, Math, as well as Stat. Okay, so let us assume that only ComSci faculty teaches programming courses and that every DPSM faculty has a math background, and we have predicates DPSM of X, which means that X is a DPSM faculty. ComSci of X means that X is a ComSci faculty. Similarly, for math of X means X is a math faculty. Stat of X means X is stat faculty. And teaches prog of X means that X teaches programming. And has math DG means X has a math background. Okay, suppose we have this statement, every ComSci faculty teaches programming, and we want to translate this into a predicate na logic. So we have to consider the domain. So every ComSci faculty, such that this ComSci na faculty belongs to the domain of DPSM na faculty. Okay, so assuming first that we have a predicate teaches prog of X such that X teaches programming courses. And first, let us consider this unrestricted na domain translation for all X or for every member of the DPSM na faculty. X teaches programming. Okay, so since this is tied to conjunction, the universal na quantifier is tied to conjunction, we can express it using this statement by simply plugging in every member of the domain DPSM faculty in the predicate teaches prog of X and connect them with AND. So then we can achieve truth value for each. Okay, so since the ComSci na faculty teaches programming, like Ambita, Kalaor, Dimson, they will result to true, and the rest will result to false. So then, this whole expression, or this universal quantifier for all X in the DPSM faculty, such that X teaches programming, will all result to false. Okay, so but this is not what we wanted, because it is true that every ComSci faculty teaches programming. Okay, and this does not represent the statement that we want. Okay, so what we have to do is to restrict the domain. So remember that the universal quantifier is sensitive to false value, right? So what we did was we applied the predicate teaches prog to every object in the domain of his course without focusing only on the comsign faculty. So instead, we can implement a restriction rule such that our restriction is we make a hypothesis. Okay, since as I have mentioned, we are dealing with a universal quantifier. So as you can see here, we have the statement or a restricted domain translation of this statement. Every ComSci faculty teaches programming courses, and we can express it with a restricted domain translation for all x such that ComSci of x teaches programming x. So note that we are using an implication, and what we did was we made ComSci of x as a hypothesis. Okay, so assuming that the x is belongs to the domain BPSN na faculty. Okay, and so this is equivalent to this expression, wherein we simply plug in each element of BPSN faculty to this predicate ComSci of x implies teaches flow of x. So then it evaluates to true. Okay, so by having the restricting condition ComSci of x, we're making this a hypothesis. Any input x that is not a ComSci faculty will not be considered. Okay, so because this predicate ComSci of x implies teaches prog of x will give us a vacuous truth, and it will not affect the whole statement or the whole universal quantification statement. Okay, remember that the universal quantifier is sensitive to false value. So we have grayed out this non-ComSci input like Chavez, Tainolo, Abacan, who belong in the math and stat faculty to help you see it better. Okay, so as you can see, even if it is true, it does not affect the whole statement. Okay, so now imagine if we do not use the implication and rather we use the and na connective. Okay, for all x such that x is a ComSci faculty and x also teaches programming. Okay, and we can express that using conjunction. So as you can see, we use the and na connective. Okay, and you can see that for non-ComSci faculty members, it resulted to false. Okay, so then the whole expression also resulted to false. So why didn't it work? Again, the universal quantifier is sensitive to false value due to the logical connectivity. So let's also try to have a statement. Some faculty members or some ComSci faculty members do not teach programming courses. And we want to convert this into a predicate or translate this into a predicate logic. So first, consider this unrestricted domain translation. There exists X such that X does not teach programming, wherein the X belongs to the domain of BPSN na faculty. So since we are using an existential quantifier and this is tied to this junction, so we can express this in the form of disjunction. So we have simply plug in all members of BPSN faculty to this predicate and connect them with OR. So we have not teaches, prog, and then beta, fertile organs, etc. Okay, so then we can obtain a truth na value. So this will evaluate to true or false na values. Like we have assumed that beta does not reach probe, hala, or and so on. So this results to true. To false, I mean, the whole expression has been evaluated to true. So there is an error here because this statement, some ComSci faculty members do not teach programming courses should be false because we have mentioned in our assumption earlier that every ComSci faculty teaches programming na courses. Okay, so the existential na quantifier is sensitive to true value, and we should avoid considering those input that are not ComSci because it affected our statement. So what we can do is to add a restriction rule by using an and connective. So we connect these two predicates, negation of teaches probe or does not teach probe, and ComSci using and to only consider the ComSci from the domain. Okay, so consider this restricted na domain translation. There exists X wherein X belongs to the DPSM faculty and that X is ComSci and they also do not teach the programming courses. Okay, so we can express it or using this expression. So we simply plug in every member of the SM faculty to this predicate, okay, or to this statement. And then we can see that this will all evaluate to false. Correct now, because indeed there are, it is not true that ComSci do not teach programming. Okay, so when X is, let's say, Chavez or Reynolo or Abacan, who do not belong to the ComSci faculty, it will not affect the whole na statement or this existential na statement because they are not ComSci. Again, we just focus on the values that is produced by ComSci. So let's try